All right, today we're going to talk about adding and subtracting fractions and how we do that. We're going to practice on a calculator, which makes it really easy, but I'm going to teach you kind of how we would do that if we did not have a calculator to actually type in fractions, or if we were using a basic calculator. So the first thing we need to understand is what an equivalent fraction is. This will help you to manipulate fractions so that we can then add or subtract them, because when we add or subtract, we have to compare fractions that have the same denominator. So coming back to this, what an equivalent fraction is, fractions are equivalent if they can have different numbers, but they're still equal, meaning they have the same value. So in this example right here, if I had 3/4 and I do 3 divided by 4, you see that equals 0.75. And then 6/8, well, that also equals 0.75. So they're different. They look different, but they have the same value. Now, one way that we can always come up with an equivalent fraction, and this is what we are, one way of translating into adding and subtracting fractions is we can just multiply the numerator and the denominator by the same number. So let's say I have 21 over 3, and I understand this is a improper fraction because the number is bigger than this. Actually, we'll just go with it. So if I wanted to make an equivalent fraction to this, well, I could just multiply the same number by the numerator and the denominator. So I can say, hey, I'm going to multiply both of these by 2. Now, if I draw a line here, you see 2 over 2 is 1. And when we multiply any number by 1, we still get the same number. So that's kind of the theory, or the mathematics behind how we make equivalent fractions, and it doesn't change the value. So if I have 21 over 3, I can do 21 times 3. Or sorry, but that times 2. So 21 times 2, and that gives me 42. And if I do 3 times 2, that gives me 6. So these would be equivalent fractions. So to make an equivalent fraction of something else, you can multiply the numerator and the denominator by the same number. All right, that's going to come into play when we're adding and subtracting fractions to make sure they have the same denominator. So 21 divided by 3, we know is 7, and 42 divided by 6, well, that's also 7. Again, they have the same value. All right, so understanding how we make equivalent fractions is important to this next part. Let's say I'm going to do one more example here. Let's say I have 5 over 6, and I want to make an equivalent fraction of that. Well, again, you could pick any number you want. I can say I'm going to multiply by 21. But if I multiply 5 by 21, I have to multiply 6 by 21. That will also give me an equivalent fraction. So 5 times 21, that gives me 105. 6 times 21, that gives me 126. And again, if I look at the values of 5, 6, and 105 over 26, well, 5 divided by 6 gives me 0.833 repeating, so 0.83 repeating. And if it's equivalent, then this should be the same. 105 divided by 126. Oops, I did 150 there. So 105 divided by 126, and then it gives me that same answer. So you can see how we come up with those. Okay, so now let's get into when we're going to use that. Well, adding and subtracting fractions is a pretty straightforward concept, especially if we're comparing two fractions that have the same denominator. So if they have the same denominator, we're just going to add or subtract the top number and keep the same denominator, and then we would reduce at the end. So in this example, since we have the same denominator as 6, my final answer is going to have a denominator of 6, and I would do just add the top. 1 plus 4 would be 5, 6. And then I would make sure that they're reduced either by prime factorization, which is a method we talked about before, or typing that into a calculator to make sure it's reduced. So that's always the easy way. When they have the same denominator, just add or subtract the top number. Now, when we don't have the same denominator, we have to manipulate it a little bit. So we have to come up with equivalent fractions to 7/10 and 1/3 that have the same denominator, because that's the only way we can do it. All right, so the first step would be to find a common denominator for both. Now I say the easy way, when I say multiply both, I mean multiply both denominators. Denominators. I don't want to say demon, that is evil. So if I look at this, to come up with a common denominator between 7/10 and 1/3, I can just do 10 times 3, and that gives me 30. So I'm going to write up two equivalent fractions that have a denominator of 30. Now, how did I come up with 30? Well, I did 10 times 3, right? So I multiplied that by 3. And I multiplied 3 by 10. That's how I got the 30. Now, we have to make an equivalent fraction of 7/10 that has a 30. So whatever I multiplied on the bottom, I multiply on the top. So I would multiply that 7 by 3 as well. 7 times 3 is 21. So that would be my equivalent fraction. 7/10. Again, if I look over here, 7 divided by 10, that equals 0.7. And 21 divided by 30, that also equals 0.7. So I came up with an equivalent fraction here. So for 1/3, I multiply by 10. So up here, I also have to multiply by 10. 1 times 10 equals 10. So again, 1/3 has a decimal 0.3 repeating, 10 over 30. I then came up with 0.3. All right, so that's the easiest way to come up with two equivalent fractions. Now that we have this, we can just add or subtract the numerator. In this case, 21 minus 10. So 21 take away 10. That gives me 11. And I put it over the same denominator, which would be 30. All right, and then at this point, this is already reduced, because sometimes if you're doing it the easy way, like I say, but just multiplying the two denominators together, you're not always going to be reduced in that fraction. So one suggestion you could do is go to your, we had that Desmos calculator that I've used before. So here's that calculator that's accessible online. So again, I'm going to check to see if 1130 is reduced. So I can just type in 11 over 30. Oops. And I can see over here, I'm going to switch that to fraction, and it's still 11 over 30, so I know that it's reduced. So that's a way to check to make sure they are reduced without doing the prime factorization. All right, let's go ahead and we're going to try one more problem here, just to practice. So I just made a random fraction problem here with different denominators. So we have 7 over 11 plus 8 over 13, kind of a nasty looking problem. But we need to now figure out how to add these together. So like we talked about before, we need to be able to have a common denominator. The easiest way to find a common denominator is just to multiply the two denominators together. So what I'm going to do is do 11 times 13. And that gives me a denominator of 143. So I'm rewriting the problem with these fractions with a denominator of 143. But now I have to figure out what the numerator is going to be. Well, again, with 11, I multiplied it by 13, so I have to multiply the 7 by 13. So 7 times 13 gives me 91. And then over here, for the 8/13ths, I multiplied 13 by 11 to get 143, so I'm multiplying that by 11, which I already did. So now I'm just showing that I'm multiplying 8 by 11 as well. 8 times 11 is 88. Now I have two equivalent fractions, and you don't have to check these, but if I do 8 divided by 13, that's 8. That's 0.6153, whatever that is. And 88 divided by 43 should be the same thing. Divided by 43. So again, oops, by 143. So 88 divided by 143 equals that 0.165, whatever. So we know that they're equivalent fractions. Now all we have to do is add the top number. 91 plus 88. That gives us 179. And then on the bottom, we keep the 143. All right, that should be reduced, but again, you can go back through and you can check your calculator. So I can double check over here. This is going to give us an improper fraction. So let's see if this calculator does that. So again, I'm doing 179 over 143. So on the top, 179 over 143. And you can see here it still gives us, it doesn't reduce. There's the decimal and there is the fraction. So since it didn't reduce over here, we know that it's already in its lowest terms. But again, that's how you would add or subtract fractions going through those steps.